Hi everyone, and welcome to this video. So today we're going to build upon to what we discussed in a previous video. If you haven't checked it out, it's about introduction to linear regression, understanding the concepts, and just the introductory video on how linear regression is implemented. You can find the link in the description video below. And today we're just going to build upon it and discuss how do we do that in R. How do we go ahead and just build a linear model in R and just see how it's implemented. So the steps that we're going to follow, we're going to import the data, explore the data, and see how the data behaves. We're not going to conduct inferential statistics so that the video can't be so long, but that's the entire process that you're supposed to follow. Then build the model, interpret it, and evaluate the model. We're going to use medical data, and for this we're going to predict the medical cost based on some predictors. Some predictors, I'm going to see how they behave. And the first step is just to go ahead and import some of the packages that we're going to use. Read Excel to read the data, dplyr for data manipulation, and just the pipe operator and some functions that we're going to use. Then ggplot2 and ggthemes for visualization. Then we're going to have choroplot to help us just plot the correlation matrix. Then gtsummary to have the tables. So I'm going ahead and just import the data. So in order to do this, I'm working on the same repository where my data is, and just to show you what this works in, this is the data that we're going to work on. And I've linked the description in my YouTube channel where we'll be able to get this data in full. And what it has, it just has two sheets. The first sheet is the healthcare data that you're going to use, and the second one is the codebook just describing the variables that we have. So in our instance here, we're going to use healthcare data, and we have 10 columns in this data set and 100 observations. And this is just what we have here, and we're going to just import directly. So I've gone ahead and just imported it already in my data set. Then we're going to perform some exploratory data analysis. The first one is just to check the structure of the data using the str function. So we're going to pass str function, then the data. And when we see in our data set here, we have 10 observations, the 100 observations, 10 columns, and age, BMI, sex, medical cost, region, diabetes, yes or no, and this is what we have in our data set. We can also go ahead and just see a summary. Use the summary function just to see the summary of every column in the data set. For continuous variable, we'll be able to see the distribution, the minimum, the maximum, and so forth. And also you can just explore more and more variables. You can also use the summary function of the TBL summary in gtsummary. And what I've done here, I've just taken the data, then used the pipe operator, which is found in the dplyr or the tidyr libraries. And what I'm going to do, I'm just going to pass TBL summary. Then within TBL summary, I'm going also to use the function type. And in type, I'm going to create a list. So I'm going to say list. I'm going to define what my variables I want them to behave like. So I'm going to define age as continuous, so as a continuous variable. Then BMI as continuous, blood pressure as continuous. Then also medical cost as continuous, but also important, because remember we had variables like smoker, which is smoker yes or no. We want them to be displayed as no, yes, in the data set, in the table that we need, and they are categorical. And then we're going to use we need these several statistics for continuous variable, all continuous. We need the median, we need the 25th percentile, the 75th percentile. Now with this is just Q1 and Q3. Then we need the mean, the standard deviation, the minimum, and the maximum. This function is the package TBL summary has a lot of functionalities, and we in the series videos we're going to see how we are going to be using them even and more and more. So it takes a little bit of time to run, depending on the processor and depending on the size of the data. Sometimes it takes a little bit more, but once we have it, it generates a table. Let me zoom in. Let me just zoom in and so that you can see it together. So what we have, you can even have some more customization, such as the file name and so forth, the file name of the table. You can even change the column, the year, instead of blood underscore pressure to write it blood pressure. You can bold, but let's see what we have. So remember, for continuous variable, we said we want to see median and the first quartile and the second quartile and the third quartile, and then the mean and the standard deviation, minimum and maximum. We can also see for smoker, and we can see there are 76 individuals who are not smokers, and then 24 individuals are smokers. Then the exercise frequency, 0 times a week, 1, 2, 3 until 6. And then we have the sex, male or female. We have 51 females and 49 males. So this is a very beautiful table. You can copy it and Excel and just use it in your description in your documents. Then you can check for missing data. We didn't have any missing data, so we have zero missing data. We can also do some visualization. So like here, we went ahead and just had a ggplot of healthcare data and then generated a histogram. So histogram where we fill with this color and have a black color that just lines the histograms. And then also have a density plot. So when we run this code, just to give us an overview of the distribution of the data, what we see here, we see that we have this is our histogram of the medical cost, and we can see that the distribution is slightly skewed to the right, but we can see many participants, many individuals are within this range here. I think within 12,000 here. But this is just giving you a high level overview of how your Y variable is behaving. You can also have a box plot of the data, and it's really important because it can help you just to see. You can see here's the median value around 12,000. Then you can see there's potential outliers in the data set, so it can just help you just identify some problems earlier on. What we can do, we can just go ahead and have box plots for maybe based on some categorical variables. You fill by whether a person is smoker or not. You can also fill again by region, but I'm just going ahead and have all of these categorical variables at once. So I'm going to also import reshape2 and stringer that will help me convert the data from wide format to long format. So how does this look like? So currently you can see our data. This is how our data is. We have 100 observations, but we want to change them into long format. So in order to do this, I'm going to use the pivot longer function, and my column names will be sex, region, smoker, and diabetes. Then I'm going to move the names to categorical variables and the values to category. So this is what we're going to use. And when we see our data, our long format data, it now has 400 observations, and this is how it looks like. So it just converted the data into long format. So the reason I'm doing this is because I want to have a box plot for everything. Once and once. So this is what it does. So we take the data, the long one that we converted, and then aesthetics are going to be Y, X is the category, and then the Y is the medical cost, and we're going to fill also by category. Then we're going to see a facet wrap, and just a facet wrap. The facet wrap will be based by the categorical variable, and then we want 2 rows of that facet wrap. Then this is just our title, and then some more themes formatting. So let's see how it looks like. So what we're going to see, we have this beautiful graph here where we have the diabetes, we also have sex, we also have category and region, and also smoker and region. So you can see overall, like people who have diabetes have a little bit higher medical cost. You can see males have a little bit higher. We have smokers have a little bit higher, and of course people who are coming from north. You can perform also inferential statistics maybe to get more. The last idea that we're going to do is just to see the correlation matrix between the continuous variables. And here I'm going to extract the continuous variable using this numeric function, and just generate a correlation matrix. So the correlation matrix looks like this using the core function, which is in base R. And in order to visualize it really well, I just went ahead and I generated this correlation plot. So this is what we have. You can see this correlation. You see the correlation between age and medical cost is 0.31. A little bit on the, it's a positive, towards the strong positive correlation. We see that we have age and the BMI is decreasing. So this can help you understand whether your X variables are correlated in any way, and maybe just move ahead and identify some problems earlier on. Remember, we don't want multicollinearity when performing linear regression. So we are going to go ahead just, and now the main step, just to build the linear model. And here we need to use the LM function. So the LM function, then pass in the Y variable in your dataset, then use the tilde function to just say versus and dot. So it will be Y versus everything. I'm using the dot function so that I don't need to list everything, age plus sex plus region plus and so forth. I don't want to list that. Then data equals to healthcare. Then I'm going to assign this to an element called medical cost. The next thing, just so this variable medical cost has a lot of elements, and we can see inside here, when you just try and go ahead and just see medical cost from here, it's a list of 13 variables, 13 elements. We have the coefficients, which will be our estimators that of interest, the residuals, the difference between y and x. We also have effects. We also have the call. We also have the term. So it's a large element that has been built by this model. So the most important thing for us is now the summary. So because it tells us now how the model is. And I'm just going to go ahead and explain each and every estimate elements that we have here. So the first thing, we have the call, and the call is just how the formula works. Then we have the summary of the residuals. What is the minimum residual? What is the maximum? What is the first quartile? And so forth. Then we also have the coefficients. So remember, we had our main goal was just to understand how do these coefficients work. So the first coefficient is the intercept, and this is what we had as the beta naught. So what it tells us is the expected value when everything else is 0. When we have all x being 0, what is our y-intercept? So here, according to this model that we built, is that given that every estimate is 0, every predictor is 0, we expect that the medical cost to be 469 USD. We also have age, BMI. So for BMI, we have, like, given your unit increase in BMI, you expect the medical cost to increase by 184 USD. Similar to cholesterol level, given a unit increase, we expect it to increase, the cost to increase by $9. What I also will explain here is the smoker. So this compares, it's given us, yes, so given a person is a smoker, the unit cost will be 50.65 compared to the one who is not a smoker. So that's the value what it tells the model tells us. And for the region, so the region, our reference group now, it has given us now for the people who are in north, south, west, and it has used east as the reference. So given a person is from north, the medical costs will be increasing by 316 USD compared to a person who is from east. So we also have diabetes. We see people who are diabetic will pay a little bit higher compared to those who are not diabetic. For exercise frequency, so as exercise frequency increases, we expect the medical cost to decrease. When you have a negative sign, we expect it to decrease. The other things that we have in this summary, we have these coefficients. So this will just tell us whether this estimate is significant. So the probability of the estimate, is it significant or not? And the other thing we have, remember we talked about the R squared, where it just explains the percentage of variability. We have a slightly variability explained. So we have explained 88.17 variability in the y variable using our predictors. Also the overall significance of the model, we have it here. Lastly, the last thing we're going to do is just have generate the plots and see how they behave. So we're going to see how the plotting the model and just see how it behaves. So we're going to use this plot function in R and just see how it behaves. So we have 4 plots. I'm going first to generate all of them so that we go line by line and just explain. So the first one that we have here is the residual versus fitted. So remember from the first video we explained how these plots work, and they will help us just to check the important assumptions such as the variance. So do we see, like, if there is an equality of variance? So we expect all our residuals versus fitted to be within this range here, this range, and not have a shape like a funnel shape. If we have a funnel shape like coming from up here and down here, it means our variance is not constant. So but if we have a slightly shape that looks the same, like box shaped, or just a line but not a final shape, meaning our assumption of equality of variance has been held true. We also wanted our residuals to be standard normal, meaning mean 0 and variance 1. So we see we want all majority of them to lie within this line, and this is what we have. So we also have the other functions that just help us to check, the other plots that help us to check now just the equality of variance, and also important the outliers. So we see there are 3 observations that have been highlighted that may be of concern a little bit. Observation 73, 74, and 35 maybe may warrant further investigation and so forth, also in the residual versus leverage. Yeah, so there we have it, guys. We've been able to build a linear model in R. We were able to import our packages, critical packages such as read Excel to help us import the data. We did some visualizations. We did have a look in the structure of the data, did some visualization of the Y variable just to get to understand our data more. We also came across and built the correlation matrix just to see how it behaves. Then finally we fitted the linear model using the LM function and just got to explain what the estimators were and assessed the model diagnostic. So that's all we had for this series. This is the second part of this series. Remember, if you didn't have an opportunity to check the first video, you can find it in the description. The link to the GitHub where we have the codes and also the files is attached also in the description box. The next video will be just trying to replicate the same example using Python. And so until next time, stay safe, guys. Bye.